Hello, I'm Hubbert Smith. I'm the founder of i4Ops. How many of you all are contractors or do data science for as a consultant or contractor? Show of hands. Nobody? Excellent. Fair enough. All right. So the rest of you, no, making a joke. I'm happy to have you all. So what we're going to talk about is preventing data breach. And let me frame up this problem. So of this presentation, we're going to have these three takeaways. First, the establishment that data is a business asset, so it needs to be protected. Now, I'm not talking about publicly accessible data. I'm not talking about social media. I'm talking about business data like supply chain or energy production or things that run a business. And the relevance here is that these are the data use cases that will drive contractor business. My motivation of starting a company is to see the data science market grow. And that requires data science tech talent, contractors, and it requires data. So the end customers who are going to pay for these projects, they need to be comfortable to present their data to the data scientists. And the problem that we ran into was that if we are contractors, and I was a contractor recently, like you, and we bumped into a problem where the chief information security officer said, "What keeps my data from walking away?" And you'll hear this several times, so I apologize in advance of repeating myself. But because of this, we recognize that this risk, the risk of insider data breach, credentialed user data breach, is a project blocker. And we believe that if we resolve this blocker, if we have a good answer for that customer question of what keeps my data from walking away, then we tend to accelerate the practice. More contractors get work, more data science projects happen, more worldwide benefits happen of improving supply chains, improving energy production. This is a big picture thing, but we've got this blocker that gets in our way. And what I'm going to do in this presentation is I'm going to contrast penetration tests from exfiltration tests. And exfiltration tests will be a new concept for you. I'm pretty sure of this. And then the last part of the presentation, we'll go through how to remedy this. And we've worked out a reference design that fundamentally is cloud native. It keeps the data in. So hopefully when your customers who want to do a data science project come to you and say, "What keeps my data in?" then you'll have a credible answer. You'll have a professional answer. So that's what this presentation is about. So I mentioned this particular thing. What keeps my data from walking away? I had this question put to me by a CISO, Chief Information Security Officer, in the real world. What keeps our data from walking away? So I want to unpack that because there's some business consequence here, and then we're going to get into the technology. So I know that this is a technical audience. We'll get to the technology. So this particular customer was a $1 billion a year customer. They did freight forwarding. It was like a travel agent for freight. They booked freight like containers and trucks and trains and so forth from point A to point B. International travel, specialty booking like refrigeration stuff, secure stuff like pharmaceuticals. They had this fairly rich practice. And the problem that we wanted to solve for them, we as data scientists wanted to help them with, was the problem of data breach. So this freight forwarder obviously it's a $1 billion company, so they had a long list of customers. Some of those customers would just say, I'm going to stop doing business. That's what customer churn means, is they just simply say, I'm going to find some other supplier. By the way, every company that has customers experiences customer churn. So this is a pretty relevant data science task to reduce customer churn. There are examples of code out on the internet. You can train yourself. I've written that stuff myself. It's not that hard. And it's real high value. And this slide is intended to show you this. So going back to this customer, $1 billion a year. And they said, we have 20% customer churn a year. That's just an estimate. I'm going, that is a $200 million problem. So we were honest about it and said, there's no way that we can solve all of it, but we can solve 10% of it. And we can use data science observability to solve 10% of that customer churn, which is really pretty cool. Not only can we claim it, we can do it, and we can back that up in a contract. So pretty cool stuff. So 20% of $1 billion is the cost of customer churn is $200 million. What our project solved was $20 million. That's a pretty good number. And we can say that value, that business value to you, is significantly higher than the cost of our project. So let's go ahead. And they went, oh yeah, let's go ahead. Then their chief information security officer gets involved and says this: what keeps our data from walking away? What we experienced was this: a 13-week blocker. 13 weeks is a quarter of a year. So again, straight line math, and the numbers are a little bit simplified, but they are pretty accurate. We spent 13 weeks fumbling around to figure out who had what credentials and who had a sysadmin and how we were going to get in and signing NDAs and so forth. And this actually is pretty short. It was the right question, but it was the wrong answer. We didn't have a way to prevent, to meet this request, to keep their data from walking away. So that was the genesis of the company that I started. So straight line math, if you've got a $20 million annual problem and you waste a quarter, guess what? The customer loss here was $5 million. And obviously we as contractors took a hit on that too. So bad things happen, but there is a way to fix this. So that's the personal experience. Now let's zoom out a little bit and talk about the bigger business picture and the bigger picture of data science and consulting. So what's new now? Why is our world different now than it was, say, 5 years ago or 10 years ago? And the difference is this, that companies, and I'm talking about commercial application like shipping, receiving, logistics, energy, those companies are now realizing that data science is a real competitive tool. And not only that, if they don't apply data science, they fall behind competitively. This is a realization of these people that run these commercial businesses. So you have valuable business data. You have data science to produce actionable outcomes from that data. So we know that there's demand there. We know that there are resources there. The other side of the coin there is that data scientists are in a shortage. There's a worldwide shortage of data scientists, but data science tech talent is very much available as contractors or gig workers or so forth and so on. So this is the intersection that we're trying to attack, or attack's the wrong word. This is the intersection in which we are solving a problem for the customer. So I want to ask some questions real quickly. Show of hands, please. Data science. Do we believe that today's data cybersecurity, like keeping the data in or securing against infiltration, do we believe that that's sufficient today? Anybody? You say it's sufficient? Fair enough. I'm going to convince you otherwise. Any other votes here? So does RBAC, roles-based access control, does that keep your data from walking away? If you're already in, right? If you have that role, yes, no? I agree. How about pen testing, penetration testing? How many are familiar with penetration testing? Yeah, good, most of you. Does anybody do exfil testing? Exfiltration, the opposite of penetration? No? Okay, that's right, because it doesn't exist yet. Just throwing it out there. So in the interest of these two questions, pen test and exfil test, do we think that our data is safe from exfiltration? Have I convinced you, or are you still skeptical? It's fine to be skeptical. I hope you will. All right. So thank you for that. And by the way, in case anybody doubts that data exfiltration is not a problem, if anybody thinks data exfiltration is not a problem, doubts it, it's a thing, I would refer you to this. There is a partial list of data breaches. It's a Wikipedia, and it quite literally is list of data breaches that you can Wikipedia, and it will show you a horrifying list of all sorts of data breaches and the root causes and who and when and what was taken. The important thing about this list is it is incomplete because there are so many of these data breaches that we never know about or are never published, or even if they are published, don't make it into the Wikipedia list. Nonetheless, there is a very compelling list of data breaches that are worth looking at. And trust me, every competent CISO has looked at this list. They know about this already. And again, my intention here is not to put anything down or be negative. My intention here is to be positive and help you prepare for this question. My intention is to help the data science community be competent and prepared and have a good answer for this question. What keeps my data from walking away? So I got one more business slide and then we're going to get into some technology. Today, this is an important issue, is businesses like the logistics business, they have a choice. They can say, well, I'm just going to lock my data away. I'm going to not expose it. I'm going to not take that risk, but that keeps them from innovating. Or I'm going to expose my data to employees and contractors, and that creates a risk of data exfiltration. So going back to my example of this logistics company, that project that I mentioned, we saw 8 years of every customer transaction that they had. If that data had gotten into the hands of their competitors, use your imagination, that would be really bad. The competitor would be able to say, oh, well, I can see these are my 4 biggest customers. I'm just going to go after them, right? So really bad things would happen. Bad business consequences would happen if this protection did not happen. So let's get into some technology. What keeps my data from walking away? Well, the first realization here, and this is our stack, and part of this is a reference design, and I'm happy to walk you through all of it. Well, I am going to walk you through all of it. The first thing to recognize is that we have some new tools to work with. So we have the cloud. That's very cool. We have Kubernetes. That's very cool. We have virtual machines that can run inside of Kubernetes. Super cool. So let's figure out how to aggregate these existing technologies and enhance them to solve the problem of preventing data breach. And really the keystone, and by the way, this is a commercial product, not gonna be shy about that, but it's also made of open source components mostly. And there's a lot of things that you can do without involving me. Fundamentally, I hope you do involve me, us, but there's a lot of stuff that you can do on your own, and I'll walk you through what that means. So we have this concept of a cloud native workspace as a data science project. The important point here is that we're not network cybersecurity. We're not trying to harden an entire enterprise. We're trying to harden a project. So this by definition makes this task simpler and doable. We don't have to be somebody like a Palo Alto Networks that starts at $1 million. We can do this for $1,000, $2,000, $5,000. The point is that we're hardening up a project. We're keeping the project data in. So our stack involves Kubernetes clusters. We happen to use K3s for some reasons that are not showstoppers. K8s will be fine. We use virtual machine nodes, so we're using VMs, not containers. These are easier to secure, and I would encourage you to go after KubeVirt. It's not for the faint of heart. It's not easy, but there are some very real reasons to go with virtual machines for security purposes rather than containers. Exfiltration testing is a thing that we've pioneered, and you can pioneer them too. But the way that we thought about it was, well, if we tell our customers that we can keep the data in, that we can prevent exfiltration tests, that we can prevent exfiltration. How do we prove it? So we wrote a handful of Python scripts. It's pretty simple, 30 lines of Python for each one of these that said, oh, I'm just going to try and exfiltrate something from this protected area. And it'll either say exfiltration was prevented or it was allowed. So this is a thing that gives your customers confidence that you're doing what you say that you can do. The other thing is that what we wanted to do was to create this cloud native workspace for data science. So obviously we have to put some data science tools in there. So we simply provision these virtual machine, they're pods inside a Kubernetes clusters. We pre-populate those with VS Code, with RStudio, with PyTorch, with Keras, with Scikit. These are just executables. You install them just like anything else in Linux. One of the other important catches is that this Kubernetes cluster and the virtual machines need to support GPU pass-through. So this is essential in data science because data scientists use GPUs. I'll take a sidebar here real quick. There is a really good tutorial on the internet by a Stanford professor. It's a 2-hour lecture on YouTube that walks you through how to do a large language, like a toy model. I went through that. I ran it once on a regular server, desktop really. It took 30 hours to train. I ran the same code on a similar desktop with a GPU. It took 30 minutes to train. So this, the use of GPUs is not a nice to have. It's kind of a must have. So I would encourage you to take a look at that if you're going to be doing anything like this, is to make sure that you take a look at GPU pass through. One of the other things that I'll call your attention to within this cloud native workspaces, our company has a thing called Zero Exfil. This is a module that actually prevents data exfiltration. That's going to be hard for you to write. Talk to us if you really want to see it. But what is not hard for you to write is to demonstrate to your customer that you have taken measures to secure the work environment and that you have monitored exfiltration in a way that alerts them immediately if exfiltration happens. So that is a giant step forward. I'll offer this other piece of insight. As we built the company, I did a thing called validation, market validation. It's a fancy term for ask a lot of people the same questions. So I asked 170 people involved in data science, cybersecurity, etc. I asked them the same list of questions. Do you use external tech talent? Contractors, consultants, 100% say yes. 170 said yes. 0 people said no. Does the involvement of external tech talent cause delays? 100% say yes. Delays can be either paperwork delays or credential delays. Next question is, what is your method for reducing data breach, for reducing your risk of data breach? 100% of them say, well, we use NDAs, not non-disclosure agreements. Yeah, there you go. I laugh too. So you don't have any monitoring, you don't have any enforcement, you don't even know if bad stuff has happened. And obviously I asked the next obvious question was, well, are you satisfied with that? And every single one said no. Another little subtle data point was 5 out of those 170 people said, well, we have physical security. And I said, so tell me about that. And he said, so we have buildings with a metal detector and with security guards, and you leave your devices in your car and you walk into work. And I said, well, are you satisfied with that? And they said, no. Have you heard of Snowden? It's like, FYI, Snowden was a contractor. He worked for Booz Allen Hamilton. He was in arguably one of the most secure computer facilities in the world. It is an NSA facility. Well, it was up there. All he did, and I verified this, all he did was go into work without his cell phone, without any USB drive. He punched a hole in the network. He went home and he exfiltrated all of that poop that ended up on WikiLeaks. So the point is that keeping the bad actors out is not a solution. Keeping the data in is the solution that I believe that the world needs to see. So let me continue my journey here. So we talked about this. We talked about exfiltration. We talked about the data science environment. We talked about GPUs. Let's talk about this stuff over here, and then I'll end up with the storage bits. So we've got this container, the set of virtual machines running in a cluster. How do people use it? How do you get to it? Worldwide tech talent. That's what we're trying to enable. So we've got this concept of data scientists, and they actually access this Kubernetes cluster with zero-tier VPN. It's just a good old virtual private network. This is one of many. Zero-tier works for us for a number of reasons. It's simple and so forth. There are others that will work fine. But the idea there is that you have an encrypted connection between a data scientist and a Kubernetes cluster that may happen to be in another time zone. Okay. The next thing is this concept of CASM VNC. So CASM VNC is a virtual desktop. So the idea there is that they need a data science toolkit to work from. So they need to use VS Code and RStudio and PyTorch within this container. So they access that via this CASM VNC, which is a virtual private desktop. The important thing there is that no data gets onto the data scientist endpoint. The only thing the data scientist sees are via a browser, they see bitmaps. So they see a desktop, but the data and the stuff that's running the desktop is actually still running here within the container. So if no data gets to the endpoint, what that does is it disallows any user, credentialed user, employee, contractor, consultant, from copying the data onto a USB drive, from losing a laptop, from pushing data to GitHub, which happens all the time, regrettably. So the idea is they get their work done. It's smooth, it's friction-free, and the data stays within the workspace. The other thing to remember is that cybersecurity people and infrastructure people are invariably oversubscribed. They're always too busy, too many fires going on. They will never pay you enough attention. You say, hey, I want to do a new project. And they go, I'll talk to you in a month. Okay, can't have that. That's a delay that is costly. So what we've done, and what I'd encourage you to think through and maybe do some of this for yourself, is we've created this easy button. So virtual machines, you can pre-engineer those. That's pretty readily available stuff. Just like you're going to pre-engineer a Docker container, you can pre-engineer a virtual machine. You can use a whole bunch of Kubernetes clusters and deployment tools and YAML to simply have an easy button to say, hey, I'm going to give you just 3 or 4 pieces of information. I'm going to give you my name. I'm going to give you a network IP. I'm going to give you a server location, and I'm going to give you some storage. You fill that in, hit go, and this thing is pre-deployed. The important point here is that it's pre-deployed and pre-secured. So the security is already pre-engineered. The exfiltration test comes with the deployment, and this can be conducted via a project manager in minutes rather than months. The point is that these projects will spring up. You're securing a project. So this is going to happen often. It's not like you're going to secure an entire enterprise and I don't have to do it again. We'll have project after project after project. And that's what we want, right? So we want this to be really easy. You want it to be auditable, etc. Now, the last thing that I want to talk about is the storage. So the thing that we found out as we built this thing was that data security, and this is going to sound so obvious, but it's so true. Data security is a data problem. It is not a network problem. Cybersecurity is a network domain. If you think about all of the cybersecurity folks, it's all about a network, but data security is about the data. So we pay a lot of attention about how we connect our digital workspaces to existing data. Fortunately, there are really good tools that can securely connect the storage. So Longhorn Storage is think of it like a storage shim, a sidecar that allows you to connect to an S3 bucket, or allows you to connect to local SSDs running on, say, a bare metal system upon which this is running. So Longhorn's a big facilitator for us. Longhorn has data encrypted at rest. Longhorn has data encrypted in motion. And we can control the access via Kubernetes secrets, which is really pretty cool. So again, this is one of those things that you can pre-engineer. Just fill in a couple of blanks and the deployment will do the rest of the work for you, which enables this. The last thing on this slide, and I'm going to take a breath, is if you look through that Wikipedia list of data breaches, what you will see is there are a large number of data breaches that were due to sloppy cloud credentials. So what happened was somebody had some S3 credentials just to the raw S3 blob and said, yeah, it's easy to guess, or I'm just going to tell somebody. And, so sloppy credentials is really a big deal. So the way that we approach that is we say, well, we have encrypted data in motion. That in itself does not solve the problem, does not improve your security posture is the fancy way of saying it, because there's always this back door directly into the storage. But if you implement this, and the data scientists can get their work done, then you can turn this off. You can revoke these credentials. That's easy to do. It's not terrifically technical. You simply look at the list of accounts on that S3 bucket and turn them off. Then your security posture is demonstrably better. And that's another thing that will improve your credibility with your customer. Okay. Any questions on this? I know that that's a lot. Almost out of time. Okay. So I'm going to wrap. I'm going to blast through this. So I'm a recovering program manager. So the way that I approach the world is you have a problem that you want to solve and you have success criteria that shows that you have solved it. So that's what this is. Success criteria is we're going to improve data security with exfil sensing and logs and actual prevention. There's a stack that says I'm going to test against Linux copy. I'm going to test against FTP. I'm going to test against a git push. I'm going to test against email it to myself, which is all doable. You can do all of this in Python. It's trivial. Okay. I'm going to wrap. So my wrap is this. Today we're focusing, cybersecurity in general is focusing on penetration tests. Tomorrow we really need to revert and change our focus to exfiltration tests. And the result is that we improve the time to value for both the company and the contractor. And that's my end result is I want to see the data science world bloom. And if we get this blocker out of the way, it can and it will bloom in a very relevant way. Not Twitter scraping, but supply chain logistics for energy production, for pharma, for things that really matter. And by the way, if things really matter and have money attached to them, that's good for the contractors. They can earn a living at it. So peace. Thank you so much for your time.